Hello, this is Artem from xCAD, and in today's video I'm going to show how you can simply start developing your own applications for CAD systems. We will learn how to install and use .NET templates with xCAD.NET to create add-ins and standalone applications for SOLIDWORKS and Inventor. We'll start by installing xCAD.NET templates. Let's run the command prompt and type the following command: .NET new install xCAD.templates. This will download all the templates from NuGet and install into our system. xCAD.NET templates can be created from a command line. That means that all the development environments could be used to create your projects in xCAD.NET, such as Microsoft Visual Studio, Visual Studio Code, or JetBrains Rider. Let's create sample SOLIDWORKS add-ins in Microsoft Visual Studio. We need to run Microsoft Visual Studio as an administrator in order to properly register SOLIDWORKS add-ins. So let's select right mouse button and click on Run as Administrator. Now let's create new project by clicking Create New Project button. We can see all of our templates installed in the system. We can select a filter to xCAD. As you can see, there are 4 templates installed for C#, and there is also a template installed for Visual Basic.NET. So let's start by VB.NET, click on Next. Now we can specify the name of our project and the folder where we want to create that project. Click on Next, and here we have several options, such as selection of the target framework. My recommendation when building the SOLIDWORKS add-ins is to use .NET Framework. Although xCAD.NET supports .NET 6 and .NET Core, I still prefer using .NET Framework when creating add-ins, because add-ins are integrated solutions and potentially there are some conflicts with other add-ins, and SOLIDWORKS is not yet officially supports .NET 6, .NET 5 or .NET Core for the add-in development. You can additionally customize the code for creating your template project. You can add a command manager with buttons, property manager page, and also a macro feature. I will not be selecting the add macro feature options here because I'm going to show you another template which is specifically designed for developing macro features in SOLIDWORKS. Now we can click Create button to create a scaffolding of our project. All the files have been added. You can review the code. There are some comments available to better explain how that code works. It's quite different approach compared to the standard SOLIDWORKS APIs. You can put breakpoints here. So this code also shows the property manager page. The property manager page class is defined here. Template also installs the debug profile, which you can automatically run and attach to SOLIDWORKS. If you have a SOLIDWORKS installed in a different location, you can simply change that path. Now we can click on Run SOLIDWORKS. This will launch SOLIDWORKS and attach to it automatically. So you can see we can debug the code. OnConnect function is called every time our add-in loads. So we created the command manager group and property manager page. Let's create new part file, and let's also navigate onto the menu and command tab bar. You can see there is a new button added to our command tab, and there are also a couple of buttons available in the menu. So one is About, and one is Create Box. When we click this one, Property Manager page appears, where we can select a plan where we want to create our box, and we can specify the parameters. Once green tick button is clicked, we are back to Visual Studio, where we can debug our code. As you can see, it passes the parameters we specified in Property Manager page. We create sketch using the xCAD.NET APIs. We can also use the standard SOLIDWORKS APIs, like in this case using the one to create extruded feature. So you can see here we have a final result. We can now close this file and SOLIDWORKS to stop the debugging session. If we want to uninstall our add-in, all we need to do is to clean the solution. This will run the process of unregistering our add-in from the registry. So you can see here it's unregistered SOLIDWORKS add-in and all its COM objects. Let's continue our demonstration and create new SOLIDWORKS add-in specifically for macro features. Macro feature is an advanced mechanism in SOLIDWORKS API, allowing developers to create their own SOLIDWORKS feature, which will be very similar to the standard features of SOLIDWORKS. Those features can produce geometry, expose dimensions, can have property manager pages while adding or editing, can have preview, and much more. Let's say we want to create a custom feature to create cylindrical geometry in SOLIDWORKS. And instead of creating this using standard elements such as extrude, a sketch, we want it to be a new feature which user can edit it should have its own custom property manager page where user can enter parameters such as height of the cylinder, diameter of the cylinder, and the location. xCAD.net provides an example of doing that in C#. So let's select the C# filter and let's select xCAD SOLIDWORKS macro feature template. Let's specify the name of our macro feature. We can keep it as it is. Click on Next. Here we have few options. Similar, we can select a framework. Let's choose .NET Framework 4.8. And we have some additional options which we can select to create our macro feature. You can hover your mouse to learn more about those options. Here we have a project, also filled with comments to explain how this feature works. One of the first steps to do when creating a macro feature is to define its data model. So this is data required for the developer to create a feature. So for example, for cylinder, it could be a plane or face where we're going to base our cylinder, radius, height, etc. And this data can be provided by the user via property manager page. Next, it will be passed to the function which is going to use this data and call some APIs to create a cylinder. So create geometry is a function which is going to be called whenever we change the selection in our property manager page. So let's start the debugging process and see how that works. All macro features are file specific, so we'll need to create a new part to create this cylinder feature. So let's start new part, have a new command called create cylinder. When we click it, we have a property manager page appears, and you can see this create geometry is called immediately. It has default parameters, and if we cannot create a feature within default parameters, we're going to throw an exception, like in this case. We need to select a plane or planar face in order to create our cylinder. And this message will be translated to the user. So when we try to commit that property manager page, we can see that error. So let me just try it again. So we have selected the face now, and you can see we're now able to generate a geometry just using some APIs and returning this result. Now let me remove the breakpoint to show how that works in action. So let's come back to SOLIDWORKS, and you can see we have a preview of our cylinder, and whenever we change the parameters, this preview is dynamically updated. When I click green tick, new feature is added into the SOLIDWORKS tree, and you can see it looks very similar to standard feature. It has dimensions, and we can modify this dimension using instance 3D, or we can double click on that dimension to change its value. We can also link it to another dimension, or for example use SOLIDWORKS design table to drive its parameters. We can also edit the feature, and for example in this case we can change a parameter such as reverse, and now our direction of the cylinder has changed and our model has been updated. We can also use a face to create a dependent feature. Let's say we do it reverse. We have an option to specify the different values for the radius and height. And for example, we can specify that to be a cut. So you can see our preview is now changed. The original body will be acquired by a new feature and the cut will be created. Of course, if you save the model and open this model again, all the features will be available. It is possible to interact with those features in the exact same way with any standard feature, so you can suppress it, delete it, you can apply any other features on that one. For example, you can add fillet or extrude. So let's clean the project and continue with our presentation. In the next part of the video, we are going to talk about cross-CAD development. If you work with multiple CAD systems, you may find that those are different but very similar in a way. So all of those have some common features, such as sketches, 3D geometry, which is created as a result of applying some operations such as extrude or cut. There are also some metadata associated with the files, custom properties in SOLIDWORKS, iProperties in Inventor. There is also a possibility to create a family of parts such as configurations in SOLIDWORKS or iParts in Inventor. And when you develop an application for CAD, you would like to reuse your code as much as possible to use the same code base when targeting different CAD systems, so it's much easier to implement new feature and to maintain the existing code. One of the fundamental ideas of xCAD was exactly that, to introduce a cross-CAD development possibility. xCAD framework is built with multiple layers. There is a base layer which does not target any specific CAD system, and it is a CAD agnostic layer. It consists of common elements of all CAD systems, such as parts, assemblies, drawings, such as properties, configurations, bodies, geometry, etc., etc. Those base interfaces are implemented for a specific CAD system, such as SOLIDWORKS, SOLIDWORKS Document Manager, Inventor, etc. Of course, it is not possible to unify all of the APIs under the common interface. That's why we'll have a specific function in each of the specific xCAD implementations, such as SOLIDWORKS, and you'll be able to access a direct API from those interfaces as well. The idea of xCAD is to make common interfaces for the most commonly used features. One of such features would be opening files and reading custom properties from all of the levels, from a file, from configuration, and from cut list. In the next section of the demo, I will demonstrate how to create a project template and read custom properties from files, configuration, and cut list in SOLIDWORKS, SOLIDWORKS Document Manager, and Inventor using the same codebase. Currently, xCAD provides two templates for cross-CAD development. One is for console applications and one is for WPF applications. So let's start our demo by creating a new xCAD WPF application. As usual, we need to specify the project name, so let's call it sample WPF. Click on next, and here we have a few options. So similar to before, we can select a target framework. Because it's a standalone application, we can use .NET 6 or .NET 7, and I'm just going to use .NET 6 for this project. And we also can specify the implementations we're looking for. So SOLIDWORKS, SOLIDWORKS Document Manager, and Autodesk Inventor. So I'm just going to check Autodesk Inventor to create the projects for that as well. So click on Create, and now we have our project scaffolding created in Microsoft Visual Studio. So let us inspect the code and let me explain how that works. UI project will contain model, model view, and view classes for our application. So as you can see, if we look at the packages used in the project, we can see there is no reference to any CAD specific libraries. There is only reference to base library of xCAD. So here we have a UI, which we're going to be loading the properties. So it consists of a data grid where we're going to render our properties, the version of application we want to read properties from, and the file we're going to browse. So let's now look at the base class. So this one is the most interesting one. This one contains the actual implementation of reading the values of properties from files, configuration, and cut list. But also this project does not contain a reference of any CAD specific library such as SOLIDWORKS or Inventor, and it operates with IX objects from xCAD.net, which is a base class which are CAD agnostic. So let me just expand dependencies and you go to packages, and you can see there is no anything like interrupts of SOLIDWORKS or Inventor. However, if you look at the SW project, this is an actual implementation, and this one contains a reference to SOLIDWORKS library, and if you expand the compile time assemblies, you can see there are actual interrupts for SOLIDWORKS in this project. This applies to other specific implementations as well. So for example, in Document Manager implementation, we have a Document Manager reference and Document Manager interrupts. And also the same in the Autodesk Inventor project. So if you go to packages, you can see there are Autodesk Inventor interrupt. But what is very important is that actual code used in these specific implementations is very minimal. So we have some assembly level attribute for WPF, and we're just creating the window from our shared UI class and just providing some starter calls for the specific CAD system. Apart of that, there is no other code, as all the business logic is implemented as a common base project, which is using the xCAD.net base CAD agnostic layer. Let's start SOLIDWORKS implementation of that project and see how it works. So I'm just going to make it as a startup project, and I'm just going to click play to start the application. So it's going to launch our user interface, which is created in Windows Presentation Foundation. So you can select a version of SOLIDWORKS. So I have two versions installed. Just select 2023. Now you can just browse for the file I'm going to open. Now the SOLIDWORKS instance is created in the background to open the file and read the properties. So I'm just going to put a breakpoint in my base project. So this is the one which is reading the properties with a CAD agnostic way. So we'll see that we're going to reach that breakpoint. So we are here now. So we are going to open the file, we're going to fill the table with the data. So we're going to firstly read the properties of the document and put it into the data table. Then we're going to check all of the configurations of that file and add the custom properties from each of the configuration into the table. And we'll do the same for cut list custom properties. So I'm just going to continue my project. So when it's finished, we're going to see the data table populated with the data. So you can see here all of our custom properties. So we have several columns, which is file configuration and cut list, and the corresponding custom properties in the table grid. Now let's test the same scenario, but now using SOLIDWORKS Document Manager. So SOLIDWORKS Document Manager is a library provided by SOLIDWORKS, allowing you to read and write some metadata to SOLIDWORKS files without SOLIDWORKS API. So you can actually access this directly from a file without the need to open the file in SOLIDWORKS, which makes it much faster. The API itself is very different structure to SOLIDWORKS API. So if you ever written anything in SOLIDWORKS Document Manager, you will see that it has very different classes. So code from SOLIDWORKS will not be compatible with the code for SOLIDWORKS Document Manager. However, in xCAD, we will use the same code to read the properties from the SOLIDWORKS files using Document Manager. You need to request your own SOLIDWORKS Document Manager key in order to use SOLIDWORKS Document Manager API. So now you can see we have the same user interface appeared on our screen. We can select the same file or different SOLIDWORKS files if you want. So for example, let's select the same pipe file, click on open, and now we reach the same base code in our API. So we're going to run the same API functions to read the data, but now we're actually deleting that through SOLIDWORKS Document Manager API. And you can see we have all of our data grid populated with the properties. You may notice there are more rows displayed in our grid. This is because SOLIDWORKS Document Manager API allows to read configuration-specific cut list properties. Let's continue and launch Autodesk Inventor implementation of the same project. So let's click F5 to run the project. Again, we have exact same user interface appearing on our screen. Now we select this Inventor version. So let's now select one of the Inventor part files. Click on open, and you can see we have an Autodesk Inventor opening in the background, but we're going to reach exact same code in the base class to read the properties. In all three cases, we use an exact same code to read the properties from the files. Let's continue and load all of our iProperties from Inventor and populate the data grid. So far, I have been using Microsoft Visual Studio to debug and create my projects. And the final part of my presentation, I'm going to show you how to create a console cross-CAD project using Microsoft Visual Studio Code. Let's start by creating a new folder for our project in Windows File Explorer. So let's call it Sample Console. Now let's open Microsoft Visual Studio Code. And we can simply drag and drop our folder to make it a working folder in our VS Code. Now we can open the terminal in order to run several commands. Okay, so let's run .NET new list to see all the templates installed in our computer. So you can see there are several xCAD templates. We can just use their name to create a new project. So .NET new xCAD console, if you type a help parameter, we can read the parameters available for this specific template. Those parameters correspond to the options you see in the user interface when creating project in Microsoft Visual Studio. So you can specify the framework, and you can also specify what implementations you want to use, such as SOLIDWORKS, Document Manager, or Inventor. Let's go ahead and create a new project using the default framework, which is in this case .NET 6 for SOLIDWORKS, SOLIDWORKS Document Manager, and Autodesk Inventor. So when we run the command, you can see the project structure has been created in our Visual Studio Code. It has a similar layout to the project in WPF, so we have a properties reader which is implemented using the base xCAD API, and we have a specific implementation for Inventor. So I'm just going to put it at 2024 because this is the version I have installed on this machine, the one for SOLIDWORKS and the one for SOLIDWORKS Document Manager. Solution has been also automatically created and all the projects are added to the solution. So now we can just run .NET build in order to compile this project into the executables. This sample project will open and read properties of all files passed to the executable via arguments. So let's navigate to the output folder. We can go to bin, go to debug, .NET 6, and we can just run the command line here, and you can just drag and drop the executable and pass the file path as a parameter. Click space, let's open some SOLIDWORKS file and click enter. And now you can see SOLIDWORKS is opening in the background, file is opened, and all the properties are read and printed into the console. We can do similar steps with the Autodesk Inventor executable. So here you go, opening this one. In a very similar way, just going to pass the path to the Autodesk part as a parameter. Click enter, and now Autodesk Inventor is run as a background, file is opened, and all the properties are read and printed into the console. Thank you for watching this video. You can find more information about xCAD.net in the description.